Solve the equation 6x squared minus 13x equals 15. Well, to solve an equation, it's pretty universal that whatever the variable is that appears in the equation would establish our goal as would be x is our variable equals a number. X equals a number. And of course, part of the goal is make sure that x has a positive 1 coefficient, so we're reporting to someone what 1x is worth. What's the number that 1x contains as a value? Okay, but when we look at our equation that we're asked to solve, we see two instances of x. One is to the second power, and one is the other instance of x is to the first power. Now, the exponents on variables help us predict how many solutions that we could expect. When x to the second power, we actually expect 2 solutions for x. As many as 2 solutions, so that by the time we are honing in on the solution, we actually expect to get 2 different numbers for x, as many as 2 different numbers. So our goal for a quadratic equation, which is what this is, when there's a variable squared, we call the type of equation that contains it as a quadratic equation. And there's a special way to solve, several ways, but the one we're going to use today is with factoring. We're going to solve this quadratic equation by factoring. Okay, let's go ahead and get started. First of all, to use factoring to solve a quadratic equation, let me make sure we copy this correctly. 6x squared minus 13x equals 15. To begin factoring as an approach, we need to make sure that the equation is written in standard form. Standard form of an equation requires that all the terms appear on one side of the equation equals 0. The reason we're subtracting 15 from the right side is to make make this equation equal 0. And then the reason we're subtracting from the left side is to make sure that the equation remains in balance. Whatever we do to one side of an equation, we do to the other. Okay, 6x squared minus 13x minus 15. That 15 doesn't combine with any terms because it's a constant. These other 2 terms are variable terms. Okay, so now we have the equation in standard form. We have all the variable and constant terms equal 0. So we now are going to begin factoring the polynomial that's on the left side. Now, we usually would try to factor by looking for a GCF, but 13 is a prime number and 15 and 6 are not multiples of 13, so there is no GCF. We're going to factor. Now, we'd have to factor because let's go ahead and analyze this. What we have here is ax squared plus bx plus c. We have a trinomial to factor. And because there was no GCF, we can't shrink down this leading coefficient to a 1. There's nothing to take out to reduce this 6 to a 1. So we're going to identify this as a trinomial of the form ax squared plus bx plus c. There's a plus to match this plus. B is a negative 13. There's no plus to match this plus, so we insert 1 again. We're using, in both the middle and the last terms, we're using the concept of additive inverse. Instead of minus a positive 15, we're adding a negative 15. That helps us identify A, B, and C. Because what this is leading to is, let's use, we're going to use the AC method of factoring, which is also known as, aka, factor by grouping method. The AC, we're going to use AC and B, of course, to find a pair of numbers to split the middle term, and then we'll have a 4-term polynomial. After that, once we have a 4-term polynomial, we of course would factor by grouping a 4-term polynomial. Okay, so let's make a couple of tables here to perform the factor AC method. We make 2 tables, or 2 big tables. just by making two giant capital T's. This first table, we need to find the factors of the number that we get when we take A and multiply by C. Okay, this is kind of the idea of the AC method. It comes perhaps from this table. All right, A is positive 6 that we see, right? And C is negative 15. Positive 6 times negative 15. To make sure that I don't make a mistake, I'm going to go to my calculator. Positive times negative makes negative, and then 6 times 15 makes 90. So we have negative 90. We're looking for the factors of negative 90 in the first table. The second table, we're looking for the same pair of numbers whose sum would also make B when we add them together. And B is negative 13 in our problem. Okay, so here's the summary so far where we're at in our problem. We're looking for two numbers ultimately. Two numbers times each other that make negative 90. And those same two numbers that when we add them together, we make negative 13. Okay, we always start on the factors table. Start on the factors table to look for numbers that multiply together to make negative 90. Let's use blue. Let's see if I can change this color. Let's use blue. All right, so negative 90. If we start factoring that, well, sometimes, a lot of times I'll go ahead and try A and C and see if A and C will work. Sometimes that's like an easy way to get factoring done. But when we look at A and C in the sum table, because we know they're going to work in the factors table, when we look at them in the sum table, they add up to get a negative 9, which is not right. So we can abandon using 6 and 15. They're not going to add up to the negative 13 that we need. So let's go back to the drawing board and see what other numbers we could use. Like, I don't know, 9 and 10. But one's got to be positive, one's got to be negative. When we try these, positive 9 and negative 10, they also are not correct because they add up to a negative 1. So they're not right. They're not getting us the negative 13 that we need. Now, if I've already tried a couple of numbers and I'm not finding what I need, sometimes I will just break down these numbers into 4 other numbers, or just as many numbers, smaller numbers as I can, and recombine them somehow. Like, we've already tried, see how 3 and 2 make 6, and 3 and 5 make 15? We've already tried those numbers, and we've already tried 9 and 10. I want to look for some new combination, like what is 3 times 3? 3 times 3 will make 9, times 2. That makes 18. Look, these 3 numbers times each other make 18, and then that leaves the 5. Here's a new number combination. And we're trying to make a negative 90 with multiply, so I need to make one of these numbers negative and the other number positive. So notice what I did was to come up with numbers that I couldn't imagine in my head. 90 is like a weird number for me. I can't imagine what numbers would multiply to make 90 other than 9 and 10, for example. I wouldn't have even come up with 6 and 15, but they were A and C. So, but when I break the numbers down and recombine these really small numbers into 2 numbers, I think we actually have found the numbers that we need, because negative 18 plus positive 5. It's like I owe somebody $18, but I can only pay them back 5. What would that come out being? I still owe them 13. These are the correct numbers because they work in this table. We know because we got them from the factor trees. Negative 18 times positive 5 makes negative 90. Works in this table. These numbers work in this table, and they also add to negative 13. So these are the numbers that we're going to use to split the middle term and factor this polynomial that we have on the left side. So let's see if we can just continue factoring down here. Our original polynomial is 6x squared minus 13x minus 15 equals 0. And what we're going to do is copy the first term out, give a little room. What we're doing is we're making room in the middle. Remember, this is part of an equation, so I wrote equals 0. And we're going to split, this is called splitting the middle term into two terms. So the two terms we're going to use are, we're going to bring over the 18, the negative 18, and I'm going to write that. 18's got a factor of 3 in it, and 3 and 6 have a factor in common. 18 and 6 have a factor of 3 in common, so that's really good. In fact, the entire 6, when you include there's another 2 in the 18 and a 2 in a 6, the whole 6 is going to be a factor in common. So there's the reason why I'm putting the 18 in the blank next to the 6x squared. And I'm going to put the other number, this positive 5, in the other blank. And many of these problems are written such that the second number out of our tables has something in common also with the last term. It kind of just helps that these, helps support factor by grouping. Now, these two blanks, these two terms, new terms in the middle, they have to add up to the term that we're splitting. And notice that the middle term also has an x in it. So we just glue an x right next to these numbers from the table. Okay. Now, I'm going to copy this up here. Copy this whole thing up here. And we're going to continue factoring. I just need more space. 6x squared minus 18x plus 5x minus 15 equals 0. At this point, everything we've done, we've used the AC method. Now that it's a 4-term polynomial, we're going to factor by grouping. Now, at this point, we're going to factor by grouping from here down. The left side of this equation. Factor by grouping. Okay, factor by grouping says, I'm going to look in the first two terms to see if we can find any kind of common factor. It wouldn't be a greatest common factor, but it's a common factor. And what we see is, for sure between the two terms, there's an x in common. So we write out an x. Then we also know that there's a 6 in common. And what this is going to do is it's going to leave behind a remaining polynomial in between these green parentheses. And what is that going to be? Well, if we use a positive 6x and times whatever we need to put in this blank to get positive 6x squared to come back, we need positive times positive to make this positive. 6 times an invisible 1. Let's just not write that in. And x times another x to make 6x squared when you multiply these two together. Now, if we distribute this common factor to the second blank, we need to make a negative 18x come back. And we need to put anything we need, we need to find anything we need to put in this blank to make this negative 18x come back. Positive times negative makes that negative come back. 6 times 3 makes the 18, and x times, well, actually we don't need any more x's because we have all the x coming out from this, coming back in to the product to make the 18x coming from out here with this red x. Okay, I copy this. I have asked my students to copy this polynomial, this remaining binomial, right under the last two terms. And what we have is a positive x minus 3. We're just copying that. And then I asked my students to look for what we would need to put in this blank so that this, whatever we need in here to make positive 5x come back is what we need to write in. We would need a positive times positive to make this positive. And we also need a 5 times that invisible 1 that we didn't write in. 5 times invisible 1 makes 5. And then here's where the x is coming from. So this, in the blank, positive 5 is what we needed. Now when we distribute this to the negative 3, do we get this term coming back? Yes. Positive times negative makes negative. 5 times 3 makes 15. So it's all working. Now, and by the way, I should point out that we really need to keep maintaining that this is just the left side of an equation. As we're continuing to factor, you must keep track that this is an equation equals 0 because of what we need to do before the end. Factoring itself is not our end goal. It's just an intermediate goal. All right. What we have is a GCF of x minus 3. I mean, the true GCF, one of them, is x minus 3, as we see now. And what we would have to have is another binomial that has 6x in it is the first term, and plus 5. When we FOIL these back together, they'll give us back the original 6x squared minus 13x minus 15 when we FOIL these, if we were to FOIL them and check them. I encourage you to do that. I'm not going to include that step at this point for the sake of time, because I think you trust where we've come from. Okay, now, what we have here are two factors times each other that equal 0, that produce 0. From the zero factor property, we know that when two factors times each other equal 0, one of those two factors must be 0. So we use that fact, that property, to state in this way. Either x minus 3, this factor, either this factor is 0, and when I say the word is, I write the word equals, equal sign, or this other factor, 6x plus 5, must be 0. And when I say must be, I write the equal sign. One of these two factors must be 0. So when we state that fact and we write is and must be as the equal sign, we create two little baby linear equations that are super easy to solve. So by factoring and using the zero factor property, we've created two little linear equations. Now we finish solving. I'm going to add 3 to both sides to get the solution x equals 3. On this other equation, first I'm going to subtract 5 from both sides, and we get 6x equals negative 5. Then finish the solution by dividing by 6 of this equation, and we get x equals a negative divided by a positive is negative. That brings the negative sign out of the fraction bar, out of the fraction, and to the left of the fraction bar, over 5 over 6. Okay, what we're looking at here is x1 is 3. Or, here's that or that's kind of running between these two equations, or x, our second value, our second solution, could be negative 5/6. These can easily be checked in the original equation, one at a time. If I put a 3 in for x, we'd square it and then multiply by 6, then subtract the product of 13 and 3, and we're going to find that that makes 15 equals 15. Also, we would, that would check this solution. Then if we were to put negative 5/6 in for x squared and for x and simplify it, we'll find that that also produces a 15 on the left, which would be 15 equals 15 and true. I'll leave that check step up to you. Right now, I'm going to go look for a solution of 3 and a solution of negative 5/6 in our possible answer choices. Negative 5/6 appears here, but not with a negative 3. Our solution is positive 3. A cannot be the solution. Negative 5/6 and 0, no. We got negative 5/6, but not 0. B is not the solution. Negative 5/6 and positive 3. C looks to me like the correct solution. I'm just going to check D to make sure I don't even have a duplicate, or let's just make sure to eliminate it. We're seeing negative 5/6 and 1. 1's not correct. So D is not the choice. So here we have the correct answer choice for this problem. Negative 5/6 and 3 are the solutions, and they're shown with solution set symbols around them. This is definitely the answer choice. The correct answer choice is C.